distort. This is not happy, right? We draw out densities of states. There's energy at those density of states. Also from our intuition, or excuse me, there's states there. The bands are touching one another, which is generally unfavorable. The other thing is H2. We know H2 wants to exist. This system doesn't want to be H. You can only do that under really high pressures to make that happen. So this system's going to distort. Let's talk about that distortion. Am I okay to erase this stuff? Okay. So this is a point where chemists and physicists have a language barrier, but they're talking about the same thing. You probably talked about it in inorganic chem. I don't know, Katie, if you've had any classes that have talked about distortions. We're going to talk about the Jahn-Teller effect, which is more of the chemist's way of looking at it, and Peierls distortions. Which is the more physicsy way to describe it.
Wait, are these two like separate, or is Jahn-Teller?
Jahn-Teller is for molecular systems. Peierls is for periodic systems, but it's talking about the same thing. Okay. There's a couple different versions of the Jahn-Teller theorem that you'll learn about or can learn about. The one I'm going to elect is the one paraphrased from my inorganic chem professors, James Bowser, Dr. James Bowser. He actually wrote what was considered the best inorganic chem book out there. If you go into any of our offices, you will see it there. He quit writing it because he just got tired of doing it. But he had a website called Bowser's Blunders, where if you found any error in his book, he would give you $1. This is also the same professor. On the day that we walked in, he gave us money because he said, I make no money off of this book. Really interesting guy. He is still alive. I got to go out at some point. He offers to look at the stars, go to his house and check out the stars. He also taught a course called Scientific Revolutions, which was the best history course I took. All right. Yep, Scientific Revolutions. Which was basically a science course, but it was a history course. It's good. Okay, so the Jahn-Teller theorem. The Jahn-Teller theorem states a nonlinear. Wow, spelling. System having a degenerate ground state can't spell today. Will become non-degenerate and thereby stabilized by distortion. Let's translate this into real people speak. Degenerate, what are we talking about when we say degenerate? Same energy level. And when I say by distortion, what am I talking about distorting? Yeah, the MOs, and therefore the bonds, right? Changing bond lengths. Okay, I don't know if you talked about this in your organic classes or not. Example 1,3-cyclobutadiene. What does the skeletal structure for this compound look like? Yeah. Like that? Katie, does that mean something to you, or do you want me to draw the Lewis? Yep. Now, the symmetry of this thing is D4H. That might not mean anything to you till you take inorganic chem or a point group class, but what it basically says is this is planar and the bond lengths are all equal. Another way, a probably better way to represent this system would be through dashes or a circle around it. Okay, I need more space. I shouldn't have taken up all this space. Am I okay to erase this?
I just have a question.
Yeah, what's up, Joe?
Distortion?
By distortion, we mean bond elongation or change in the MOs.
Is this the one that's the funny thing is that
Can I erase this? Yeah. What are you saying, Nathan?
Is this the one that's a funny bending or
Yep.
is that just
Yep, that's this. Oh, well, actually,
Not
not really bending.
Cyclopropane does some really weird bending.
Yeah, cyclopropane does stuff.
Cyclopropane does some
If we draw, yep, it exists. You can get it.
I just said it hates it.
propane.
No, it doesn't hate existing. Nope, it will exist. Actually, with transition metals, you can make it persist very easily. Yeah, yeah. Lily, you're talking like a war veteran back there. I seen some things. Inorganic chemistry was my actually organometallic chemistry. Yes.
Oh, so
Okay.
great.
All right. So let's draw the Huckel MOs, and I actually believe I made you guys do this one point for this system. So how many MOs am I going to get out for this system like this? 4. Again, if you point these down in with the thing, yep, you get a diamond. What's the MO diagram going to look like? So one state, what's next? Yep. Yep. And each of these technically, side 2, side 1, phi, I'm sorry, phi, not psi. Yeah. And I had you guys calculate the energies of these things. This one was alpha. This one was 2 beta. Maybe I didn't have you guys do this one. I have you do it in echem. Yeah.
No, I remember we did this.
No, we did.
Long and painful. How many pi electrons in the system? Yep. 1, 2, 3, 4.
That it shouldn't be.
Yeah. We did it like
Yeah, you're right.
Hold on. Isn't that breakage rule? If you have Google,
Okay.
he doesn't like it when there's
Let's draw the MOs. So now these are p orbitals, but we're looking from the top down. So they kind of look like s orbitals, but they're really p's. Perfect. Okay. So remember, these are p orbitals. We're not showing the lower lobe. We're just showing the top lobe. Everybody feel comfortable with that? Okay. MO number 1. How do I got to shade that thing? Yes, don't. MO number 2. How do you want to shade that one? Okay, we can do that. What about MO number 3? Sure. And then finally for MO4. Perfect. You guys got it. Feel like masters at drawing orbitals. Perfect. Okay. So now, it's kind of interesting because you look at these two, they're degenerate. But if you were to populate one more so than the other, you'd get a bond elongation.
What do you mean by populate one more cell?
So like if this one had 2 electrons, let's call this bond, oops, carbon number 1, 2, 3, and 4. If I populate this one, there's going to be a shorter bond length between which 2 carbons? Or can you see those?
One and two.
Yep, 1 and 2 and 3 and 4, those bond lengths would shrink. But yes. And then if I populated this one more, the opposite would happen, right? Okay. If I did this, what would happen between the bond lengths between 1 and 2? Yep. What about 3 and 4? Yep. Nope, not 3 and 4. 3 and 4? What's the interaction between these two? Bonding or anti-bonding?
Oh, that's what you meant.
Yep.
Oh, okay. Oh, I thought you were removing electrons.
What about 2 and 3?
Yeah, so those would all be because
Yep.
okay, I see.
Okay. All right. So now, Jahn-Teller theorem. What's the Jahn-Teller theorem say? Yes. So we have this at a D4H symmetry. That means the system is planar. It's flat. This will be, I'll do it down here. Make it less confusing. Yep. So now, so this is where, if I draw the molecule out, it's the same throughout. What's going to actually happen to this system? Yep, it's going to warp. And what's it going to look like? Yeah. How would you describe, you could describe, if I say this bond is a double bond, these are singles, what's going to be this guy? Yep. And so this distorts. Yep. I was going to ask that of Lily. Lily, what's that going to be for point group? The what? Still flat. But what's the rotational axis here?
2. Oh,
yep.
It's 2. 2 pH.
Yep.
Yeah, I don't understand.
That's okay. You don't need to worry about it till later.
Wait, is Orbital first semester?
Yeah, it's going to be next spring or next fall. Okay, now how do these orbitals fill?
1, 2, 3, 4.
Yeah, there you go. So it's distorted, and now it's stable. Okay, now this is for a molecular system. Solids will also do this. And instead of just being called a Jahn-Teller's distortion, it's Peierls distortion. But it's the same idea.